And then there's access control. The same is true for permission management. There are 4 levels. Green here. Representative is allowed to use the current one operation permission. If we click on this, it turns gray. Then the current operator, he can't use this function. Click Save after modification. Then go to the next one is Account Security. And this is what we built. One valid day for this user. Number of errors. In this case, we entered the password wrong 3 times. Then freeze for 15 minutes. Then we can also modify this. Just save it after modification. Then go to the PID interface to confirm our temperature control and a controlled PID value. If it is at 0, then we need to click to refresh. There must be a PID value on it. What if there is no PID value? We will not control temperature and humidity. Then click Save. After confirming that our PID values are available. Then from the accessory bag, take out our factory inspection report. Turn to the factory correction parameter record table. We proofread. Click the first item first. Make a confirmation on the calibration interface. Are our parameters consistent? Then go to the next item, Equipment Debugging. Confirm a value for our filter. Are the parameters the same? Then to one of our temperature and flow parameter interface. It is in the parameter correction interface here. Then check the temperature, humidity, and flow in turn. After confirming that the parameters are correct, we can go back to the runtime interface. Then we go to the test interface. Click to run. Here are the types of experiments and sample types. Then the sample type, we choose the thin film experiment type. Here are impact line calibration and testing respectively. Then for the first time, what about the installed equipment? You need to hit the line first. Then we choose the impact line. The default is to choose this unit. Then click Start Test. In the lower left corner of the test interface software, there's a test state. It shows the operation process of our equipment. A real-time state. The test time is 1 time of the total test. Then the process time. It's a running time of our current process. So where do we look at this process? That is, there is a process setting in this debugging interface. Here are 3 patterns. So what we're doing now is hitting the line. If it hits the line, it must first control the temperature. The setting here is 2 hours. But it doesn't actually take 2 hours. It is waiting for this temperature to arrive. After the temperature we set, it will automatically jump to the next process. Then after the temperature control is completed, it will be bypassed for 0.5 hours. After rinsing for 3 hours, just carry out the impact line of a gun for 48 hours. Then we have to check, is the operating status of the instrument normal? We get it from the accessory box. Take out that 4mm PU hose. Plug it into the air outlet of the upper and lower chambers respectively. Just plug it in like this. Then we take another container with water to check when we bypassed. The upper cavity will exhale. Bubbling is observed. This is normal. What about bypassing? He didn't get angry, so it doesn't bubble up. Wait until we're done bypassing. We will enter a flushing process. What about the flushing process? Our upper cavity is out of breath. Then change the gun. He will get angry. After rinsing, then we get to the impact line of a gun. Same here, can't breathe. The next shot is out of gas. Then these states are prove that our instrument is operating normally. So after we fill the baseline, a prompt box will pop up. Prompt you a baseline result. We need to save. Then our latest voltage value. It will be automatically saved in our calibration, in the voltage value corresponding to the impact line. Now our baseline is fully charged. We can put the mouse on the very end of this curve. The impact line mainly depends on one of its voltage values. Then we can also find it in the audit trail here. Test tracking. Click to inquire. Then find the data of our impact line. Our end. The voltage at the very end is 197.052. Then compare it with our factory value. Click on the debugging interface. There is an impact line option in the calibration. Penetration 0. The corresponding voltage value is 198.875. This is a value we leave the factory because each of our sensors, its signal value is different. So what about our current device? Its voltage value is 198.875. Then compare it to the value we just filled the baseline. Normal voltage value of this impulse line can't exceed plus or minus 5. What if plus or minus exceeds 5? Secondary impact line is required. Look at the limit of the second punch. Is it the same as our last voltage value? Is consistent if consistent. Then we just need to save. The latest voltage value is enough. And we're going to demonstrate this sampling. So first of all, we have the sampler position. There is a safety buckle. When the safety buckle is locked, then this sampler can't be pressed down. So when we want to use it, you need to pull this safety buckle out. Then rotate 90 degrees to this state. It's open. This is when we sample. The sampler can only be pressed down and used. Remember to lock this safety buckle when you're done. Then we take out a sample that we need to test. Put it on the sample board. Then we place our sampler on top of the sample. Release this safety buckle. When we sample, be sure to hold the base of this sampler with one hand. The other hand presses the rotary cutter. When we cut, don't press too hard. As long as the blade can touch the sample, then press, rotate around. After one rotation, let's lock this safety buckle first. After locking, then take off our cut sample. This is a sample we cut. After we fill the baseline, standard module verification is required. Open the protective cover. Take out our wrench, unscrew the lid, and then when we sample, because it is airtight and fits well, then we can press lightly like this. After a corner is up, we can tear it off. After tearing it off, we will wipe it with ordinary paper towels. Be careful not to wipe with water. Just wipe it with a dry tissue. Then take out our bee juice. Get the right amount of bee juice. Smear on the gun cover. Then apply evenly. Note that this bee juice must be evenly applied. Then put the upper gun cover away. Take out our standard membrane in our accessory bag. This is our standard 125 micron membrane. Its reference value is 4.4 plus or minus 0.8. Take out our standard membrane, then stick it on the gun cap. Flatten it. Press lightly. Put it aside. Then take out our syringe in the accessory box. Distilled water is required. For this distilled water, we extract 25 minus 30 mol. (25 minus 30 mol). It's just the water you need to do an experiment. Insert the syringe into this lower chamber. There is one in the lower cavity cover. Big hole in the middle. After adding it, we need paper towels. Put this lower chamber. The moisture on this surface is slightly wiped clean. Then put our upper gun cover on. Tighten evenly on both sides. After screwing, then we put the protective cover on. After applying the standard film, return to the software. This is the software lock screen. We enter the password. This password, it is the same as the password of our personal account. Then click on the test interface. Click to run interface. Select the test mode on our experiment type side. What about the information in here? It's just reflected in our report header. Thickness, it is filled in according to the actual thickness of our samples. The area cannot be modified. So 50.24 is the size of our cavity. Fixed then detection unit. According to one of the units we tested. Just modify it. Then the sample name. For example, we are now 125 micron standard membrane. Then we can actually fill it in. And then the test criteria we can choose from. If not, we can modify it separately. For example, this standard. Then fill in according to the actual standard number. It is reflected in the title of the report. Source of inspection. It refers to where the sample was sent for inspection. Enter it as actually. The batch number and specifications including the inspection are the same. Fill in according to the information of the sample. Then click Start Test. Remove the 4mm PU hose from the accessory box. Plug it into the air outlet of the upper and lower chambers respectively. Just plug it in like this. Then we take another container with water. Then go check. What about when we bypassed? The upper cavity will exhale. Bubbling was observed. This is normal. What about bypassing? The lower chamber is airless, so it won't bubble. After the bypass is over, it will enter a flushing process. What about the flushing process? Our upper cavity is out of breath. Then change the gun. He will get angry. After rinsing, then we get to the eye gun. Same with an impact line. Can't breathe. The next shot is out of gas. What about these states? It proves that the operating state of our instrument is normal. What about the testing process he needs to go through? He is set up according to our process. A test mode flow. Go includes time. Then be careful. It's a gun set for 24 hours. Then if the automatic judgment is turned on, then the time for this test, it can greatly improve in efficiency. What happens when we test a sample? It will pop up a prompt box. This is what we came up with when we finished our tests. Click Close. Next, we will explain this report query. Query historical reports and where to save locations. First, we click on this home page. Then click on Reports and Data. What about here? We need to click to inquire first. Here he will show a report recorded by each experiment we do. And what about the words above? It's here to choose one of our dates. We can say choose January 2024 by December 31st, 2024. Reports made during this period of time. It will be reflected here. So if it only shows up to the current day, or accurate to a certain day, then you can choose. Let's say it's December 26th. Then start time and end time. Just choose the same day, then click Query. What about this time? What about the name of our measurement record? I will filter out some other excess experimental records for you. Only the range you selected will be displayed. An experimental record for that time interval. Then we choose. We need a record of a certain experiment. Then use the mouse to select. Then how many colors are there for the curve on our side? It has corresponding options. First of all, we only look at the transmittance in general terms. Then I don't need to look at other curves. Then we can double-click the mouse to close. Then just let it show this transmittance and this curve. So let's mouse over the transmittance curve. Which point is the mouse placed at? It will display real-time data at a certain point in your life. Then go to the curve setting. What about the curve setting here? You can choose according to our coordinates. Zoom in on one of our graphs. Suppose we have a curve of time. The maximum is 1000, the minimum value is 50, and so on. Modify it. Then click OK. Then our coordinates will change from. Only the range of 50 minus 1000 will be displayed. So how do you get it back to the original coordinates? Click the Restore button directly. Then we go back to one of our original coordinates. And we did our experiments. Click to print directly. Just print the report. File name input. Then save it to a location where you need it. Let's say I want to save to the desktop. Click Save. After clicking Save, let's go back to the table. There will be a report showing us here. Double-click to open and print. And this is one of the reports that we tested. Then print it. There is export here. It means deriving one of our experimental data. If you preview it, you can preview one of our reports. Then on to the audit trail. It has log tracking and test tracking respectively. What about log tracking? We can choose the date here. Then who is the username? There will be a display here. Your instrument is running automatically for a while. Or have you manually operated some processes? What's the matter? It will show up in this track. Then test the trace. You can also view it for a certain report. What about here? It shows us every time period. Take a real-time data to view. Again, all of this data can be exported. Then print. So let me show you a calibration method for our standard membranes. First, we're going to take a standard 125 micron membrane, and its throughput is 4.4. Plus or minus 0.8, and then we need to test. What if the test results are outside this range? Just find it in our test track. Measure a final voltage value of the standard film. See if it deviates too much. If the deviation is large, we can directly modify the latest voltage value. Then after modifying, we need to replace it with a standard film. Do an experiment. Verify to see the latest modified voltage value. Is the amount of penetration consistent? If it is consistent, the correction is complete. So what about after we test it? We need to shoot the cover. After the test, since the water in the instrument may not be used up, we need to put this syringe. We can do it like this. Use a combination of 6mm and 4mm tubes. Just don't want the original needle. Plug it into the big hole in the middle. Then pump out the water in the lower chamber. Another thing to note is that, what about when you hit the line? You need to pump out all the water in the lower chamber. Make sure it is as dry as possible. And then when we test the samples, this inferior cavity, 25 to 30 milliliters of distilled water must be added. Here we go. We will explain a daily maintenance. First of all, on this instrument, it has a yellow label on it. Here's a hint. So when do we fill the baseline? So here's the first scenario. After we replace the nitrogen cylinder. For example, after this bottle of nitrogen is used up now, replaced with a new bottle of nitrogen, then we need to refill the baseline. Go! Ensure an airtightness and purity of your piping. It won't affect the result of your next experiment. Then in the second case, do you need to fill the deadline? That is to say, do not use it for more than a month. This device, we need to shut down. Pump out the water from the lower gun body before shutting down. After pulling it out, then the impact line is required. Its time cannot be less than 24 hours. What about after filling the baseline? Our gun cover does not need to be opened. Then turn off the power to our instrument and turn off the valve switch of the nitrogen cylinder. Just shut down normally. Then there is another situation that needs to be used as a baseline. That is to say, the instrument is not used for more than a month. When using it, you need to charge a machine first. Then test your sample. And then there's another one. It's the pressure of our nitrogen cylinder. If it is less than 3 megapascals, then we have to replace it. After replacing a new nitrogen cylinder, we fill the baseline and then test it. Next, we will explain the database. Where is the backup data? So the first thing you do is you shrink it down or you shut it down. Return to desktop. Click the icon of our software with the left mouse button. Then select the open file location. Then select this TGL. So what if we need a backup? Just back up this TGL. Files with the suffix dbf. This is the database file. There is also a file for our parameter settings. It's this one. If we need a backup, is to back up a parameter setting file and a TGL file.